In the domain of science and immense enigmas, the topic of what came before the Big Bang has stirred discussions and captivated thinkers for ages. This profound inquiry doesn't merely examine how we interpret the cosmos, it pushes the absolute boundaries of human comprehension. Picture standing at the brink of existence, gazing into the vast unknown, wondering what existed before our universe was conceived. The occurrence of the Big Bang signaled the onset of time, space, and everything familiar to us. But was there a moment before this event? Could there have been a state of total stillness, a silence before the cosmic unfolding began? And if so, was it truly empty? Or did something even more extraordinary precede time itself? As we delve deeper into this question, science leads us on a voyage beyond the birth of the universe into ideas that stretch the limits of our awareness. Renowned physicist Brian Cox, celebrated for exploring the marvels of the universe, proposes that something unexpected may have existed prior to the Big Bang. He challenges us to rethink our concepts of existence and reality. In this exploration, we'll break down the science, the hypothesis, and the mesmerizing mysteries that could help explain what came before everything we know. We'll consider theories involving inflationary expansion, quantum shifts, dark energy, and even parallel universes. The revelations may astonish you, but they also have the power to reshape how we perceive our place in the cosmos. Prepare to venture into a realm beyond imagination and empirical science, a space where the unknown still weaves through the darkness, leaving scientists amazed and at times unsettled. Let's examine what may have preceded the Big Bang and why such ideas disrupt everything we assume to be true. To understand what might have come before the Big Bang, we first need to thoroughly examine what the Big Bang actually was. Scientists describe the Big Bang as the instant when the universe became incredibly dense and scorching hot, rapidly expanding, to initiate the formation of matter, energy, and the fundamental forces. When we gaze into the night sky, we observe evidence of this fiery origin, galaxies moving outward from a common point in their early history. But why did this happen? And was there a phase before this intense expansion? According to the inflation theory, there indeed was a before, and it was far from empty or tranquil. Cosmic inflation posits that before the Big Bang, the universe was cold, sparse, and relatively structureless, resembling a vast vacuum. Yet this vacuum wasn't completely void. It contained an enormous quantity of energy that drove the swift expansion of space. This expansion, known as inflation, was so rapid that it laid the foundation for everything that followed, a phase of space growing at unimaginable speeds until the process slowed, allowing the energy to convert into particles, matter, and forces, ushering in what we perceive as the Big Bang. But what was this energy? Why did it cause the universe to expand so suddenly, and what made it stop? Experts believe that this boundless inflation may have produced patches of the cosmos, each undergoing its own version of a Big Bang. Envision a limitless sheet stretching out, forming tiny bubbles here and there, each bubble representing a separate universe, including ours. This concept, called the inflationary multiverse, proposes the existence of countless Big Bangs and an infinite array of universes. Ours is just one among many. This staggering possibility challenges the very foundation of cosmology and forces us to ask what else lies beyond. The notion of absolute emptiness before the Big Bang remains highly speculative and, according to current physics, not practically real. Even if you stripped away all matter, energy, and radiation, true nothingness still wouldn't exist. Our universe is permeated by dark matter, dark energy, quantum fields, and invisible forces that form an inescapable fabric of somethingness, even in the most empty scenarios. Even if we imagined removing all these components and were left with a barren void, new energy would still emerge from this seeming nothing. This alone confounds scientists, implying that genuine emptiness may be unattainable within the framework. of our infinite universe. Space has inherent attributes, physical laws, and constants that prevent it from ever being truly vacant. Imagine crafting a space devoid of particles, radiation, and all energy. Even in this hypothetical vacuum, quantum fields and physical constants would remain. This suggests that what we call nothing still has structure. For example, there's a phenomenon known as zero-point energy, which describes the lowest energy state of quantum fields. In this condition, particles can still momentarily appear and disappear, creating a ghostly hum of activity in what should be stillness. This contradicts our classical idea of a void and implies that even before the Big Bang there was something we are only starting to comprehend. One of the most astonishing ideas in modern cosmology is the prospect of endless inflation. If inflation birthed our universe, perhaps it continues to generate new universes indefinitely. Brian Cox describes a boundless inflationary multiverse where universes are constantly forming and expanding. Imagine each Big Bang as a spark igniting another cosmos, while inflation carries on in remote regions, spawning countless others. This eternal cycle introduces the idea of a fractal universe, where every new universe could give rise to its own Big Bang. Each one would be independent, unaffected by the rest, due to the rapid separation of expanding space. For physicists, this notion is thrilling yet disturbing. It implies a multiverse without beginning or end and positions our universe as just one small piece in a vast, ever-growing cosmic network. What if there's no before or after, only an infinite, timeless cycle of formation and decay? Our understanding of nothingness changes dramatically when we look through the lens of quantum field theory. This theory suggests the universe is not merely a collection of matter drifting through space, but a vibrant lattice of energy fields interacting and giving rise to everything we observe. These fields, akin to invisible oceans, ripple with particles that behave like waves. Even in their lowest energy state, the vacuum fields are dynamic. Particles can flash into existence briefly, gain energy, then vanish, leaving behind a whisper of their existence. These virtual particles challenge the notion of a true vacuum. Imagine a universe stripped of matter and radiation. Would that be pure emptiness? According to quantum theory, no. Fields would persist, fluctuating and sometimes generating short-lived particles. This ceaseless activity and apparent nothingness tells us the universe never reaches absolute zero. Instead, it bubbles with hidden energy that defies emptiness. This insight raises another question. If energy fields spawn particles, and particles create matter, could the universe have emerged from this so-called nothing? Dark energy, the mysterious force responsible for the accelerating expansion of the universe, could be a remnant from before the Big Bang. The fact that dark energy still exists may hint at an ancient field predating our cosmos. Some theories propose that, in a more potent form, dark energy may have triggered inflation and driven the rapid expansion of space. If dark energy endures even in the absence of matter, then perhaps it shaped the conditions that allowed our universe to come into being. Could it be the hidden hand behind inflation, or even the original spark? As we entertain this idea, dark energy transforms from a passive force to a potential architect of existence, holding secrets about the multiverse. Another alternative is found in cyclic cosmology, the idea that the universe is caught in an infinite loop of creation, destruction, and rebirth. Here, the Big Bang is not a single occurrence but one phase in an eternal sequence of expansion and collapse. Our universe may have emerged from the remnants of a previous one, collapsing and re-emerging over and over again. If this theory is accurate, there may never have been a first universe. Instead, existence is cyclical, constantly renewing itself. This model also alters our concept of time, suggesting it may be circular, not linear. A universe born, evolving, dying, and reawakening endlessly would have no true beginning. Gravitational waves, ripples in space-time caused by massive events, offer another avenue for understanding pre-Big Bang conditions. If early gravitational waves were detected, they might reveal echoes from before the Big Bang itself. These signals could preserve information about a past cosmic state and serve as evidence that something existed before our universe. Such a discovery would be groundbreaking, possibly validating theories that point to a pre-Big Bang reality. As we pursue these questions, we explore ideas that push the boundaries of logic, time, and space. One of the most ambitious is quantum gravity, which aims to unite quantum mechanics and Einstein's general relativity into one theory. This union could revolutionize our understanding of what preceded the Big Bang. According to quantum gravity, space and time might not be smooth, but instead made of tiny units at the Planck scale. These discrete structures could have generated the space-time fabric we know today. In this model, what we perceive as continuous space and time only emerged after quantum fluctuations shaped them from something more primal. This radically different framework implies that before the Big Bang, reality may not have included time or space as we understand it. The string landscape arising from string theory adds another layer. It suggests our universe is one of many, each defined by different physical constants and laws. Tiny vibrating strings underlie all particles, and each arrangement of these strings creates a different universe. This framework allows for infinite possible universes, each beginning with its own Big Bang and evolving independently. This implies we're not alone in the cosmos, but one drop in a vast ocean of realities. Some theorists propose that our universe might have originated from a black hole in another universe. The singularity at a black hole's center, where density becomes infinite, could theoretically spawn a new universe. The Big Bang may, in fact, be the outcome of such an event. This idea suggests that black holes may serve as cosmic wombs, creating new realities beyond their event horizons. If true, each black hole could be a portal to another universe. Finally, the very concept of time may be misleading. If time began with the Big Bang, then asking what came before is meaningless. There would have been no before without time itself. Some cosmologists propose that time emerged from a primordial state, a chaotic quantum event where past, present, and future were undefined. Others return to cyclic time, where the universe eternally bounces between expansion and collapse. In this vision, the Big Bang is just one cycle among countless others. No beginning, no end, only a rhythm of cosmic breathing. Some theories even envision a primordial soup of particles and fields, quarks, leptons, bosons, all churning in a high-energy state before expansion. These building blocks may have existed in a quantum foam, constantly flickering in and out of existence due to the uncertainty principle. This soup could provide a bridge to the time before time. In the end, the question of what existed before the Big Bang remains one of the deepest puzzles in modern science. As our understanding of physics, space, and time advances, so too do our theories, each more intricate than the last. While we may never have a definitive answer, the pursuit of this mystery drives humanity forward, fueling our innate desire to explore the unknown.